The history of human civilization is tightly interwoven with progressing connectivity. From not records to written languages, from signals in enclosed turrets to win-win free trade, from post riders to instant communication. We never stop pursuing and redefining connectivity. Taking each step firmly, we extended connectivity into new, untouched areas beyond the known world. What wonders can we see in connectivity today? Communicate with street lamps, interact with vegetables, resurrect dinosaurs, and see them up close. Find a way out before despair. In the era when everything is connected, technology brings such imaginations to life. Data communications networks with a super capacity create order out of torrents of data. Data communications networks with intelligent experience replace best effort with SLA guaranteed forwarding. Data communications networks with autonomous driving replace manual intervention on late night shifts with network autonomy and self-healing. Today, data communications networks bursting with intelligence harness the power of the four engines: connect people, connect enterprises, connect computing power, laying a digital foundation for new infrastructure, enabling a digital bridge for all industries. Working behind the scenes, intelligent IP networks ensure shopping is more personalized than ever. Every financial transaction is smoothly made. Valentine's gifts are swiftly delivered via robots. Each question has more and richer answers. Every life receives the respect it deserves. And a new journey can be embarked on fearlessly. Connectivity will never cease to evolve, because no matter where we are, we must connect with our loved ones. And to the road we must take. Connecting value. Connecting hope. Connectivity is limitless. Connectivity knows no bounds.
Good morning, ladies and gentlemen. My name is Leandra Chinia, and I'm the Head of Enterprise Marketing in Southern Africa for Huawei Technologies. Thank you for taking the time to attend our IP Tech Summit. Digital transformation is an unavoidable way for enterprises to move towards the future intelligent world in the IP field. Huawei is not only an advocate of digital transformation, but also a positive practitioner. Today, I'm very excited to introduce you to multiple experts in the latest trends and cutting-edge IP technologies. We have an insightful agenda designed to pique your interest, and you could win one of 3 Huawei GT2 watches. In order to stand a chance to win one of these 3 watches, you have to complete the survey before the end of the event. The survey will pop up during the event, or you can find it in the lower left corner of your screen. We are honored to have Mr. Kevin Hu as our first speaker. Mr. Kevin Hu joined Huawei 22 years ago and is currently the president of Huawei Data Communication product line, and as such is responsible for managing Huawei's data communication business. Prior to this role, Kevin served as the president of Huawei's network product line and other managerial positions. He has a wealth of experience in product portfolio investment management, marketing and solution sales, and product R&D. Now, let's welcome Mr. Kevin Hu.
Ladies and gentlemen, welcome Southern Africa IP Tech Summit. I'm Kevin Hu, the president of Huawei Data Communication product line. Today, I will introduce how Huawei's data communication solution help our customers to solve issues faced during digital transformation. Why data communication plays so important role in building a digital society, and why the optimal data communication network needs to be selected during digital transformation. First, let's take China's digital policy for example. With the continuous development of the digital economy, it's more and more obvious that data becomes a new factor of production. The Chinese government attaches great importance to develop the digitalization and has repeatedly put forward the Digital China strategy and the goal of building a digital society. And the 14th five-year plan and the new infrastructure construction requirement is clearly stated that the integration big data center should be developed in the next 5 years. The integrated big data center can be used to efficiently circulated and process data elements to release data value and assist policy formulation. Second, the digital transformation of industries will be further enhanced in both width and depth. And the industrial internet will be further developed. In September 2020, the SASAC also issued a document to accelerate the digital transformation of the industry. So focus on improving the digitalization rate and the networking rate of the industry. So increasing the digital control rate and enhance the digital twin-based design and the manufacturing level. So this requires that the IP network as the mainstream of data flow provide certainty to meet the requirement of industry control systems for ultra low latency, very, very low latency. On the other hand, so the digital society will further promote the intelligent city management to achieve better city governance, people's livelihood service, and industrial development. So data communication network is the basic factor for promoting the rapidly development of the digital society and has become the foundation for building the digital society. So in the EU, Digital Europe program has become an important part of the EU's next generation Renaissance plan. So recently, the EU has launched the multiple investment plans related to digital sovereignty. In September 2020, the European Supercomputing Network, so with a total investment of 840 million euros, was officially launched. So in South of Africa region, so many countries such as South Africa, Kenya, and they also launched national strategies to develop digital economy. So next, let's look at data communication from the industry perspective. We found that the data communication industry is undergoing a great change. In 1993, Cisco launched the first switch Catalyst 1200, Microsoft launched Windows NT, and Intel launched the Pentium, we say 586. So in the past 27 years, they has formed a service delivery model. So applications and service are deployed on local servers, and the network is responsible for providing connections. The applications on the servers are connected to the office PC in the campus, so meeting the enterprise requirement for normal office environment. So therefore, enterprise network in the past was simple and did not have many complex requirements. So in this case, so all switches are used to implement the connection between PCs and servers. So today, what's changed? So with the accelerate of enterprise service migrate from the local to the cloud, OA and OT are gradually migrate from local service to the cloud. The service carry on IP network are changing. So IP networks need to ensure the service experience and reliability. So after enterprise service migrate to the cloud. So as applications and service are immigrate from local service to cloud, so the network architecture changes from the connection-centric to cloud-centric. So additionally, terminals and the access network has evolved from the tradition with a fixed line, PC, to mobility, to ubiquitous IoT terminals. So all these changes are changing the IP network. The application, the terminals are changing already. So we further enhance the collections attribution and expand the collection scope of the IP network. So this enhance, including changes in security model, flat network architecture, deterministic service quality, expand management scope, so surge of data traffic, and continuous extension of network boundaries. So IP is a technology between IT architecture and communication. So it implements interconnection between application and communication. So what's the network challenges in the cloud-centric situation? For the campus network, it faces at least 4 challenges. First, the wild area. So Wi-Fi is usually used as a supplement of wild network. So Wi-Fi coverage is deployed only in places where cabling is difficult. So the entire enterprise Wi-Fi network is dotted and has many Wi-Fi interruption points. Once users move, the service will be interrupted. The second challenge is cross-domain interconnection is difficult, especially when enterprises have new branch rollout requirement. So existing network cannot quickly connect to new branches to existing network. So the third challenge is cloud network mismatch. So however, the network deployment time is usually in weeks. A good host less a good setup. But how there is a good host? That is cloud service. But there is not a good setup. So the fourth challenge is operation and maintenance. So cloud operation maintenance is basically fully automated, machine to machine, right? But however, the network operation maintenance so requires human resource and it is inefficient. So in addition, the network problems are usually passive operation and maintenance and driven by complaints. So we cannot meet SLA assurance requirement. For the data center network, it faces at least 3 challenges. As we all know, packet loss occurs naturally on the Ethernet and has not been resolved for more than 40 years. As the network scale increase, so the packet loss rate increase dramatically. In intra-city, active storage scenarios, the long-distance transmission bring hundreds of microsecond latency, so making network flow control even more difficult to achieve zero packet loss. So Ethernet lacks efficient operation and maintenance method. In the cloudification trends, so the network scale increased by 100 times, and the relationship between network objection, such as pros and policy, so reaches millions. So manual network operation and maintenance cannot be performed. So what are the challenges to the government's intention construction? So first, the standards are not unified. In the past, different departments building private network independently with different standards, and data cannot be exchanged. So data cannot be exchanged, shared. The second, so the cloud and the network not match, and the intensive construction of cloud-based service cannot be implemented. Third, operation and maintenance cannot be intensive and require a very large amount of manpower and material support. Fourthly, the data security is crucial to government, and security intensification is crucially. So why Huawei is confident in providing a full set of network solutions that meets new requirements? So let's take a detailed look at Huawei's solution. For the campus network, so we launched a fully wireless, intelligent cloud campus network solution. It has for features. So first, so we can support all wireless networking, Wi-Fi, pure Wi-Fi, Wi-Fi only. So not just wireless access. So Huawei is the only vendor can provide independent Wi-Fi networking solution. The second, so SD-WAN, enable enterprise to form a network among their headquarters, branches, and the clouds. The third one, all scenario SD support. Actually, large-scale networking through cloud management, implement the unified management of more than 200,000 network elements. The fourthly, as data-driven network management to improve the quality of network management. The next solution is hyperconvergence data center. Huawei defined Cloud Fabric 3.0 hyperconvergence data center network has four advantages. The first, the full Ethernet high-performance computing network support, ultra-large scale zero-packet loss networking, achieve 100% computing performance release, that means double. So the second is active or Ethernet storage network, so which reduce the inter-data center connection leaks by more than 90%, especially for the fiber channel network replaced. So the third one, it is full lifecycle automation, which reduce time to market by 90%. The fourth is intelligent operation and maintenance. It's very cool. So which enable the 90% proactive fault prediction. The next is backbone network. Huawei Cloud and backbone network support one-click operation and maintenance to achieve management intensification. So one hop access to the cloud and one fiber multi-purpose. So there are four datacom solutions provided by Huawei today. So including the data center network that collects content and the computing, the campus network that connects things and people, the backbone network are connected data centers, and end-to-end security solution as well. Correspondingly, these four solutions correspond to our four products: L engine, Cloud engine, LED engine, and HiSec engine. and we hope that our solution can help customers solve various network problems during digital transformation and continues bring more value IP connections to customers through continuous technical innovation and practice. Please enjoy this event today. Thank you very much.
Thanks, Mr. Kevin Hu, for that insightful presentation. Many of you will be familiar with the world-famous research company IDC, the International Data Corporation. IDC connects the world of tech buyers with insights, intent, and engagement. IDC is the world's largest media data and marketing services company that activates and engages the most influential technology buyers. With more than 1,100 analysts worldwide, today I have the privilege of introducing you to Brandon Butler, who is a senior research analyst with IDC's Network Infrastructure Group, covering enterprise networks. In this role, he is responsible for market and technology trends, forecast and competitive analysis in Ethernet switching, routing, wireless LAN, and adjacent emerging segments such as SDN and SD-WAN. The floor is yours, Mr. Brandon.
Hi, my name is Brandon Butler. I'm a senior research analyst at IDC, where I cover enterprise network. And I'm going to speak to you today about how wireless network maturity impacts digital transformation. It's a real exciting time in the enterprise networking market right now. We see a lot of enterprises looking to digitally transform themselves, and they're increasingly realizing as they are digitally transforming themselves how important enterprise networking technology is to the digital transformation journey, and specifically how important wireless networking is to the DX journey. So let's get started. I want to level set and talk about where we are in the digital transformation journey for enterprises. IDC talks about how we are currently in what we call the third platform of digital transformation. You can think of the first platform as the mainframe era, and you can think of the second platform as being the client server era. Over the last 10 plus years, since about 2007, we have entered what we call the third platform. And this is defined by some of the new technologies that we've seen come into market in the last decade or so. Things like cloud computing, ubiquitous mobile connectivity, big data analytics, machine learning, and artificial intelligence. All of those are what we classify as the third platform. And we see three distinct stages within the third platform, which we call DX1, DX2, and DX3. So the first stage of the third platform was really around experimentation. And that was the DX1 stage. This was when the advent of some of these new third platform technologies like cloud, mobile, and social really came into place. And we now have entered into a DX 2.0 phase of the third platform, which we call the phase of multiplied innovation. This is where enterprises are using these third platform technologies, and as they're doing so, they are getting increased levels of innovation from using those technologies. So these are technologies like artificial intelligence, such as Internet of Things, blockchain, and natural interfaces. And we see platforms and communities being developed around this DX 2.0 stage. And this is basically where we are today in terms of enterprise adoption along their digital transformation journey. And we're on the cusp of entering this DX 3.0. A third stage of the third platform journey. And that is really going to be about autonomous use of third platform technologies. So this is where you get exponential value out of artificial intelligence. This is where we'll see quantum computing come and play an important role. And so some of these innovations are going to be very important over the coming years. But the key here is that in the third platform era, the network is critically important for delivering third platform technologies. And as we think about the networking requirements that enterprises have to face on a daily basis, those are continuing to expand and continuing to put pressure on enterprises as they think about their network. Now, there are three big challenges that we see enterprises facing as they're looking to digitally transform themselves and in turn transform their networks as well. One of the challenges is around the number of connections, the number of users and devices that are on the enterprise network today that must be supported. There are billions of connections that must be supported in enterprise networking today. We estimate that there could be up to 31 billion IoT devices in the world in the coming years. And so this huge increase in the number of devices is really putting strain on enterprise networks. The other factor that we see, the other challenge that we see, is the increase in bandwidth intensive applications and use cases. So if you think about some use cases like virtual reality for education or shopping or traveling or telemedicine, these are very bandwidth intensive applications that enterprises are looking to support. And that is putting strain on the enterprise network as well. And then the third major challenge is that there's this expectation of low latency connections. And so users and devices and workers and guests are expecting to have low latency connections when they're on the network. And so if you put these three factors together, it's really creating strain within enterprise networks today. And it's causing organizations to realize that if they want to digitally transform themselves, then they need to transform their networks to make sure that their networks are able to keep pace with the digital transformation that they're looking to support. And you can see the graph on this slide shows some of the important use cases that we see enterprises supporting in digital transformation. Like I talked about, virtual reality is a key one. Financial transactions that are real time, having a smart factory or a smart city or a smart car. These are some of the other use cases that combine these three challenges of more devices that need to be supported, higher bandwidth applications, and a requirement for lower latency connectivity. So as we move on and focus a little bit more on the enterprise network, these are some of the key drivers that we see driving investments in enterprise networks today. IDC recently conducted a survey of enterprises asking what are the top factors driving your organization's future investments in the enterprise campus network. And you can see some of the top drivers for enterprise networking technology today include security, user experience, and automation. These are some of the key drivers that we see enterprises looking for as they're making investments in their enterprise networks. And they're also thinking about what these enterprise networking platforms have to enable. And so they're looking for advanced automation. They're looking for advanced platforms that can enable secure policies throughout all areas of the network. Enterprises are looking to assure high quality experiences for users and devices on the network. And finally, enterprises are looking to enable advanced automation of the network as well. And so again, these are some of the factors that we see within the enterprise networking market specifically that are really driving the investments that we see from enterprises as they think about transforming their networks to support digital transformation. So let's talk about the importance of wireless within the enterprise networking market today. Wireless networks have become really a primary connectivity method for enterprises today. We've really seen a shift in the last handful of years in terms of the use cases that enterprises are relying on wireless networks for. It's really expanded from the basic Wi-Fi connectivity in a carpeted enterprise use case to this whole new swath of digital transformation use cases that we see enterprises supporting within their environments today. And they're using Wi-Fi as a primary connectivity method for many of those use cases today. So really, Wi-Fi is expanding out from the traditional use cases of delivering enterprise applications, and really it's expanding out to manufacturing and smart factory use cases, into telemedicine in the healthcare industry. There's a whole number of use cases that we see enterprises pursuing, and they're relying on wireless connectivity to enable those use cases. Wi-Fi and wireless networks also connect users and devices to business critical applications. As you think about the importance of voice and video collaboration, unified communications, and cloud-based applications that enterprises are increasingly relying on, workers and guests are increasingly relying on Wi-Fi connectivity and wireless networks to connect to those business critical applications. And there's another key here, that Wi-Fi provides granular segmentation and access controls for enterprises. This is hugely valuable for enterprises. Wireless networks and Wi-Fi specifically have really fine-grained access and usage policies that enterprises can manage within the enterprise network to enable segmentation and access controls. And that really increases the value of wireless networks for enterprises today. And so as we talk to enterprises about what sort of goals they have in supporting enterprise wireless networks today, they're looking for ubiquitous gigabit connectivity. They're looking to guarantee application and user experience, and they're looking to ease operations both on day one deployment of wireless networks and also day two management of wireless networks. And the key takeaway here for me on this slide is that you can't just rely on the infrastructure components of wireless or the software management capabilities of wireless as you think about transforming the network. Really, you need both of these components to be coming together. And we see that happening in the enterprise market today, in the wireless market today. We see advanced infrastructure components coming about with the advent of Wi-Fi 6. And we see advanced automation and software-based management platforms that run atop wireless networks that are increasingly being enhanced by artificial intelligence and machine learning for managing these networks. And when you combine the infrastructure components with the software components, that's really going to allow enterprises to meet the digital business needs of their enterprises into the future. So as a final slide here, I wanted to talk about some essential guidance for enterprises that you can think about to spur on the maturity of your wireless networks today. So if you want to be more mature in your wireless networks today, here's some advice on how you can go about doing that. Really, the first piece here is realizing that wireless maturity enables faster digital transformation. So if you want your organization to be able to be more digitally transformed, wireless networks are a key component for being able to enable that, to enable faster digital transformation. One piece of advice I would have is to enable and embrace automation over manual management wherever possible in the wireless network. Given the scale of the number of users and devices, the level of bandwidth and traffic that enterprise wireless networks need to support today, you really need to rely on automated management. If you're relying on manual management, it's just not going to be able to scale to the efficient way that is needed in enterprise networks today. Another piece of advice would be to plan for wireless investments both across the infrastructure and as well as the software management capabilities. And so again, we're seeing some advancements in Wi-Fi 6 on the infrastructure side, but also in the management platforms atop wireless networks today with the machine learning and artificial intelligence enhanced automation. One of the other trends that we see is the use of cloud managed networking for faster deployment and easier management. This is another way that enterprises are making sure their networks are more mature is having a cloud-based platform for being able to manage. Specifically, when you have multiple sites that you need to manage at once, having a cloud-based platform can be very important for that. And finally, and this is probably the most important piece of advice I have, is that to ensure that your network transformation goals align with your broader business development goals. So really, it's important to have ensure that as you're making investments in your enterprise networking technology, in your wireless technology specifically, make sure that those investments are in line with the goals that your broader business has for improving user experience or guest experience, for example, or enabling more connected devices in a smart factory, or enabling students to use AR and VR in an education setting, for example. Whatever your business's requirement and goal is for digital transformation, let that be the investment driver for investing in more advanced features within your enterprise network and specifically within the wireless network. So with that, I'm going to wrap up here. And I just want to say thanks for listening to my presentation. Thank you very much.
Thank you, Brandon, for that very interesting perspective. It is my privilege to introduce our next speaker, the President of Campus Network Domain, Mr. Lee Singh. Mr. Lee Singh has a PhD in electrical engineering and over 20 years of experience in mobile telecommunication, including 3G, 4G, and WLAN.
Ladies and gentlemen, welcome to Southern Africa IP Tech Summit. My name is Lee Singh. I am in charge of Huawei Campus Network product line, including AR access router, campus LAN switch, wireless LAN, and edge computing IoT. It is my honor to launch Cloud Campus 3.0. Campus Network is stepping forward to the cloud era from PC era. Our enterprises network today was built for the PC era 10 years ago, which connected the local office application and the wired terminals. So wireless network is only as a supplementary. But in the cloud era, application will be deployed on the cloud, while terminals will be wireless. Network is no longer just the office infrastructure, but transforms to the basis of production and service. So wired network has become a supplement, and the wireless has become the mainstream. Today, every single enterprise has taken the way through the digital transformation. In the cloud era, our IT has undergone three huge changes. First of all, the number of the mobile terminals has increased significantly. Also, large number of new terminals do not have a wired manner. In terms of the cloud, regardless whatever it is application or office, instant message or even computing resources are delivered over the internet as a service. Network as the major components that connect the terminals and the cloud has transformed to the new architecture that enable multi-branch, multi-cloud interconnection. However, what we see is that 70% of the enterprises are still built on the traditional network architecture. We need to change as soon as possible. Nowadays, enterprises are facing four challenges in the process of networking evolution. Originally, the wireless network is not a continuous network. That this continuous experience directly affects the efficiency of our business and the team collaboration. Once more, independent site network planning complicates the network sector, the speed of network, strategy upgrades, and the deployment can no longer adapt the change of the cloud service. In terms of O&M, there is no tool for virtualization of users and application experience, and there's no way to perform proactive maintenance. We believe that your campus network should have a following 4 characteristics to be able to fulfill a variety of requirements in the cloud era. First, regardless of office or production, wireless will become the first link method, which will maximize the productivity. Secondly, no matter where your global business is, there should be only one network. Third, management should shift from local to the cloud. SDN and SD-WAN implements the automated management of the entire network. Fourth, the analysis of the quantity user network based on the big data should locate potential network anomalies in the network precisely and perform proactive maintenance. Now, let's explore the Huawei's latest solution. Today, Huawei launched a fully wireless intelligent campus network in the cloud era, Cloud Campus 3.0. First, we use our leading Wi-Fi 6 technology to create a wireless network with continuous coverage. Meanwhile, we developed an intelligent optical electric hybrid campus network solution that can not only help you improve the cooperation efficiency of your enterprise, but also help you simplify the structure and reduce TCO. We take the advantage of the innovative SRv6 plus SD-WAN technology to allow you to connect the world's large and small campuses with one hop. With just the public network resources, you can get the user experience of private line. With our cloud management platform, you can manage the global network at any time, anywhere. The platform can configure your network automatically to adopt the change of cloud. Finally, we take the advantage of the AI system trained by Huawei Global Network to improve the reliability and the user experience of service, and significantly reduce complaints. Wi-Fi is quickly becoming the foundation instruction for enterprise IT. However, with the increasing application scenarios and the diversified application types, higher network requirements are posed. For example, 4K conference in office scenarios requires more than 70 Mbps bandwidth per user, and AR and VR services in education scenarios requires less than 10 millisecond network latency. In industry production scenarios, the network must be capable of zero packet loss. Traditional Wi-Fi technologies have inherent problems, making them insufficient for today's and tomorrow's applications. However, Wi-Fi 6 networks improve bandwidth, latency, and capacity, but lack deterministic invariance. Huawei has accumulated decades of wireless technologies based on the Wi-Fi 6 standards. These problems are resolved by optimizing antennas, radio frequencies, and algorithms. Wi-Fi 6 enables wireless enterprise services to experience wired networks, thereby enabling wireless services to replace wired networks. Although Wi-Fi 6 can replace wired networks, the biggest challenge for Wi-Fi network is continuous networking. Our Wi-Fi 6 products adopt exclusive software and hardware innovations, so they can enable high-density continuous wireless networking and offer the best roaming performance in the industry. The details are as follows. In terms of network planning, we provide innovative 3D planning tool to visualize simulated signals. The planning time of a 10K campus is within just 30 minutes. Huawei uses industry-leading smart antennas to achieve continuous coverage and increase the coverage radius by 20%. More importantly, signals are enhanced at any location. To address the issue of a frequent roaming interruption, Huawei introduces the exclusive AI roaming technology. This technology learns roaming behaviors of users and cumulatively guided users to roam during mobility. The roaming access rate on the entire network reaches over 96%. This innovation provides continuous and consistent experience on the entire network after large-scale Wi-Fi deployment. The speed of wireless networks has always been the ultimate goal of enterprise. To increase the speed, you must choose the most powerful Wi-Fi 6 AP. Today, I'd like to introduce Huawei L-Inchim 8760, the fastest Wi-Fi 6 AP in the industry. It has a reach of 10.75 gigabps and 16 smart antennas, the highest in the industry. Its signal strength increased by 100%. In addition, the exclusive massive MIMO algorithm improves the multi-user concurrency capacity by 40%. To meet the access requirements of more and more IoT terminals, the Wi-Fi 6 AP also has two built-in IoT card modules to easily integrate Wi-Fi and IoT. One device and one wireless network can provide wireless terminal access anytime, anywhere. The AP also has independent radio scanning capability. With this independent radio, the AP can detect network quality in real time and optimize interference without affecting wireless network services, ensuring optimal user experience of the entire network. Basically, we have mostly talked about Wi-Fi, but Wi-Fi in the end is only half of the story. We, of course, need a high quality and flexible wired network to connect all these access points and many other devices. Our latest hybrid copper fiber cables allow end users to take advantage of DC power and fiber in one cable to safely deliver over 100 watt power, more than 10 gigabps, along over 300 meters distance to remote locations where the standard power is unavailable or too costly to install. It is ideal choice for HD camera or AP's backhaul in special scenarios like a warehouse or logistics environments. By leveraging our hybrid copper fiber cables, the deployment of networks for new facilities will be greatly simplified as well. In the typical deployment scenario, for instance, office building, there could be over 1,000 employees, and everyone has 2 or 3 terminals. With our solution, you can save up 37% of your investment in CapEx and OpEx. The reduction of the usage of access switch simplifies the network architecture, thereby greatly reducing the cost of network cabling. So, Huawei's intelligent optical electric hybrid campus network can significantly reduce your investment cost for new office buildings. In addition, we have another solution that can save you money. Conventional solution requires second-time hardware replacement time to time when the customer evolves to the future target network that features multi-GE access, 25G aggregation, and 100G core. Huawei solution only need to deploy hardware devices at a basic port rate and later upgrade to the future largest network via RTU license without hardware replacement. So just pay what you use. This greatly protects customers' investment and save total 38% of the capex. Next, let's talk about how your global instruction could be interconnected. In the cloud era, the physical boundary of campus network has been blurred. How to take advantage of SDN technology to achieve fully cloud management of a global network? The network should have three features. First, it supports VPC-based model-driven, rapidly integrated with cloud applications. The virtual network is automatically configured with the change of cloud resources, which enables services fast deployment. Secondly, SDN performs network verification through exclusive DPV data plane simulation to achieve zero-error upgrades in network policy. Thirdly, it achieves one-click deployment for all entities in campus, which simplifies the whole life cycle from planning, simulation, configuration, management, and reduces OpEx by 50%. With the adoption of public cloud, reliable and efficient data interconnection is critical. How to build a high-performance but simple wide-area network? Huawei SD-WAN solution is the answer. Our solution supports 5G and wired uplinks to implement high-speed interconnection between the branches and the headquarters, as well as the cloud, helping enterprises quickly expand services. With the adoption of SD-WAN, network entities are plug-and-play, which means branches to be connected to the cloud in one hop and achieve network connectivity in one day. Finally, with intelligent traffic steering, SD-WAN makes full use of multiple link resources, such as 5G and private lines, selects the optimal links to transmit traffic of key applications, and forwards traffic of office, production, and video applications along different paths. This ensures the experience of key applications. As the ingress of the campus network, enterprise router is essential to branch interconnection. Today, I would like to introduce you our Net Engine AR, the routing with high performance and high reliability. It can implement 5G fast backhaul at any time, any place, any link. Our AR can deliver 3 times the performance of the industry average based on the advanced architecture of CPU plus NP. More importantly, Huawei's unique SD-WAN can guarantee zero packet loss. Cloudification services can help you save a lot in terms of the management of global LAN and WAN. Huawei Cloud Management implements unified LAN WAN management and full lifecycle maintenance from network planning, deployment, and optimization to inspection, and provides service experience, visibility, and fault prediction. Regardless of whatever medium-sized branch, site, and large campus with thousands of network entities, the Huawei Cloud Management platform can greatly simplify your management and reduce maintenance costs. Next, let's see how to guarantee the service and the user experience with intelligent O&M. Our iMaster NCE platform maximizes the power of AI technology and solve the actual problems of the enterprise. Huawei's terminal plug-and-play solution implements accurate terminal identification through the data flow classification. Based on that, admission to the network could be approved by just one click. Furthermore, our platform can isolate the traffic flow from rogue device automatically. The changes of network configuration are very frequent in the large campus. It is very labor-intensive and time-consuming for network verification. iMaster NCE is able to perform network simulation and verification automatically, which guarantee the zero error after the network modification. Once more, iMaster NCE is the industry's first platform that could implement unified management of one LAN, WLAN into one GUI. The fully wireless network and the cloudification of services make the complexity of today's campus network have exceeded the limits of manual network maintenance. How to easily deliver and maintain the network or keep the complexity manageable, AI and big data is what we need. Huawei's solution adopts an AI-based intelligent O&M system to continuously analyze the experience of each user in each application and at each moment on the entire campus network. In particular, the new wireless network can perform proactive optimization, which could improve the network-wide performance by 58%. Besides our AI-based intelligent O&M, Campus Insight enables virtualization of the full journey experience of end users, shifting from manual to intelligent, proactively detecting 85% potential faults and actifying faults before user complaints. How the user and application experience are improved by our powerful Campus Insight. Firstly, the 7-dimensional evaluation system intuitively displays the health status of the entire network of each region. Secondly, the autonomous driving network can quickly identify 85% of the network faults or potential risks, including common network issues related to access, air interface performance, roaming, and the devices. Thirdly, the system provides the industry's unique intelligent radio calibration function. This function can identify edge APs and predict the traffic load trend of APs based on network data of the past 7 days. And accordingly, this function performs predictive, automated radio calibration, improving the network performance by more than 50%. So far, we have been talking about the leading innovations in the Cloud Campus 3.0 solution. The fully wireless intelligent Cloud Campus network is a future-proof solution that redefines the framework of campus network. Our solution, of course, is dedicated to the digital transformation across multiple industries, namely Cloud Campus 3.0 plus X. Huawei's all-new Smart X William backhaul solution newly supports solar power supply and lithium battery power supply, as well as 5G AR uplink to ensure normal usage even without mains electricity or wired network. This solution also adopts modular design for components, facilitating on-demand configuration. Industry 5G ARs build up differentiated competitiveness and improve the reliability needed for IP-based transformation of industry devices in industries such as electric power, energy, and port harbor. we launched a Wi-Fi 6 CPE for industry manufacturing scenarios, which is significantly ahead of competitors' products in terms of performance, port quantity, and reliability. This achieves zero packet loss for AGVs, flexible adjustment of production devices, and real-time adjustment of device parameters through big data analysis. As a result, production efficiency is greatly improved. In real transport scenarios, customers require high bandwidth and reliability. Huawei's all-new vehicle-mounted Wi-Fi 6 APs can meet these expectations, such as APs support dual 5G Hz links and offers a wireless backhaul bandwidth of over 300 Mbps. Our lossless roaming technology ensures that services are not interrupted and the latency is less than 15 milliseconds when the train is moving at a high speed. Finally, why Cloud Campus 3.0 solution is your ideal choice in the cloud era? We have 4 good reasons. First of all, Huawei ranks #1 in the patent quantity rankings. We are the leading contributor in the Wi-Fi 6 industry. Secondly, we have won the 2nd place in the switch market for 5 consecutive years. Thirdly, we are also achieved #1 in the global market share of routers. Fourthly, once more, our intelligent OEM platform have been used in Huawei's own campus, serving 19,000 employees and continuously trained for better user experience. To sum up, fully wireless networking, one global network, cloud management, intelligent OEM are 4 distinctive features for our Cloud Campus 3.0. With our future-proof solution, you and your organization will thrive in cloud era by inspiring your employees' innovation, by leading the cloud instruction, by delivering the agile services, and by guaranteeing a reliable digital services. I wish you could choose Huawei Cloud Campus 3.0 solution, a truly cloud management solution for campus network in the cloud era. This is my speech. Thank you for your attention.
Thanks, Mr. Lee Sing, for taking the time to speak to us today. Our next speaker is Mr. Matamela Mashao. He is currently the CTO of Enterprise Network Solution in Huawei, Southern Africa. Mr. Matamela Mashao's experience spans 21 years in the ICT industry, with deep knowledge and understanding of multiple sectors, including telecommunications, public sector, and the financial services industry. Please help me welcome Mr. Matamela Mashao.
Good morning, ladies and gentlemen. I'm Matamela Mashao, the CTO of Enterprise Network Solution for Southern Africa region. 22 years of experience in ICT industry. Lot of experience in public sector, FSI, and enterprise sector at large. Thank you for having me. Today's topic is about Cloud Fabric 3.0, the hyper-converged data center networks that ensures the service continuity. First, let's look at what the data center network is. In a data center, the network is responsible for connecting compute and storage resources. Services expect the network to be scaled out and flexible, but insensitive to packet loss and latency. In the storage DR scenario, the network must ensure that no packet loss occurs during the long-distance transmission between the local and intra-city networks. In a high-performance computing scenario, zero packet loss and low latency are required. Data center network is also undergoing a series of changes. First, the IT architecture is shifting from centralized to distributed. Distributed networking means that the number of interconnections will increase. Ethernet networks must support large-scale connections. Second is the change of computing units. In the past, CPUs provided by IB or Ethernet interface based on the PCIe. However, today's CPUs and GPUs do not provide PCIe interface anymore and provide Ethernet interface directly. From the perspective of storage media, traditional hard disk drives moved to a solid-state drive, which is fast, while storage interface moves from SCSI interface to NVMe interface with a high bandwidth using a RoCE protocol. As we can see, the entire data center has been Ethernized and the fiber channel and InfiniBand have disappeared. This poses new challenges to Ethernet. As we all know, packet loss occurs naturally on the Ethernet and has not been resolved for more than 40 years. As the network scale increases, the packet loss rates increase exponentially. In intracity active storage scenario, long-distance transmission brings hundreds of microseconds latency, making network flow control even more difficult to achieve zero packet loss. Ethernet lacks effective O&M method. In the cloudification trend, the network scale increases by 100 times, and the relationship between the network objects such as ports and policies reaches millions, and manual network O&M cannot be performed. Therefore, future-oriented data center network needs to address the above three challenges and have the following three features: low-loss Ethernet, full lifecycle automation of data center network, and network-wide intelligent O&M. Huawei defined Cloud Fabric 3.0 hyperconverged data center has four challenges. First, the full Ethernet high-performance computing network support ultra-large-scale zero-packet loss networking, unleashes 100% computing power. Second is active all Ethernet storage network, which reduces inter-DC interconnection links by 90%. Third is a full life automation, which reduces TTM by 90%. Fourth is the intelligent O&M, which enables 90% proactive fault predictions. First, let's look at all Ethernet high-performance computing network. Why does Ethernet packet loss occur? The Ethernet network has more to one architecture. Since the upstream traffic increases, packet loss on the upstreams occurs. As services develop, the problem of traffic being transmitted on the network becomes more and more serious. Huawei uses unique eye-lossless algorithm to quickly identify network status and dynamically adjust the network in milliseconds, implementing precise network speed control and ensure no packet loss on the entire network. To ensure that AI can adapt to any traffic scenario and models, in addition to millions of real service samples, 10 millions of random samples are trained. The eye-lossless algorithm can adapt to different scenarios and ensure zero packet loss during full throughput in any scenario. In Pingyang laboratory, there are 512 nodes. As test, each 0.1% packet loss rates causes 50% computing power loss. After Huawei eye-lossless technology is used, the computing power is multiplied, and it was ranked number 1 in an AI computing power ranking according to the AI per 500 list. The second scenario is the storage network. Traditional cross-DC interconnection networks usually uses fiber channel links. Fiber channel links features absolutely zero packet loss. But in the Ethernet scenario, 70 kilometers long haul transmission, the packet loss rate reaches 0.2%. Based on the zero package technology in the data center, Huawei makes another breakthrough using the eye-lossless data center interconnect algorithm and AI-based convolutional prediction. Huawei determines random traffic and responds to traffic changes in advance, achieving lossless Ethernet transmission within 70 kilometers. Huawei's all Ethernet solution to replace fiber channel has been successfully put in the commercial use by the Bank of China. 10 100 gig lawless Ethernet links are used to replace more than 100 fiber channel links, reducing over 90% links, and customers realized the savings of more than 2 million Chinese yuan each year. The third feature is a full lifecycle automation. In traditional data center, network designs involve more than 10 indicators. The involved personnel needs to manually design items one by one and ask another department to review the design. The design takes about 5 days to complete. The verifications of the interconnection scripts of a large number of nodes takes 3 hours. Huawei uses 3-dimensional models and multi-mode evaluation based on more than 400 impact factors to generate and recommend solution in seconds. Millions of network configuration can be verified in seconds, releasing productivity in the first time. The full lifecycle automation capability enables the network to be service-oriented, flexible, and conventionally scheduled. In terms of intelligent network O&M, mainstream analysis software only solves some problems of data virtualization and provide auxiliary troubleshooting tools in a specific scenario. The overall O&M process is still in a passive response phase and depends on a manual experience. Therefore, modeling based on the network O&M KPI is still a key cornerstone of how to drive the evolution of the O&M architecture to proactively discover and automatic analysis. Traditional NMS collect thousands of KPIs. However, O&M KPIs and network configuration differ greatly. Therefore, these KPIs are discrete. Fixed rules cannot be used to describe the cause and the effect relationship between the up and down status of physical interfaces, protocol overlapping, traffic quality. To address these issues, Huawei combines the knowledge graph technology with AI to break through technologies such as automatic extraction of network objects, automatic event mounting, and automatic fault triggering and marking. Based on Huawei's more than 8,000 fault cases asset and more than 30 years of O&M experience, Huawei built a 24/7 fault defense platform, implement more than 40 topology through innovation propagation relationship learning algorithm, automatically mine more than 200 attributes and more than 1,000 relationships, and built a knowledge graph system based on a 5-layer models device, physical network, protocol, logical networks, service traffic. Based on the fault fuse interference algorithm embedded in graph, 90% of data center fault can be detected within 1 minute, automatically located within 3 minutes. With this solution, Huawei helped Turkey Bank to reduce the average fault locating efficiency from 7 days to 3 minutes. The number of users complaints decreases by 97%, and the number of daily users activeness increases by 56%. Let me finish by introducing our Cloud Fabric 3.0 hyper-converged data center network product portfolio. We have a Cloud Engine 16800 switch that can be used as a core switch. These are modular switches consisting of 4, 8, and 16 slot blade switches, supporting different line card, 10 gig, 40 gig, 100 gig, and 400 gig. First industry unique embedded AI chipset and innovative lawless AI algorithm and unique Ethernet with 0 packet loss. It can also support a maximum of 768 400 gig ports, providing an industry highest port density. We also have different access switches or top of the rack switches ranging from a 100 gig switch, 25 gig switch, and a 10 gig switch supporting deep buffer, and also 1 gig top of the rack switches and the CE8861 and 9860 series that support flexible card. For intelligent network management system, we have iMaster NCE that provide network automation and intelligent platform that integrate management, control, and analysis and artificial intelligence function. It effectively translates business intent into configuration and policies for the physical network. Lastly, I would like to say thank you very much for giving us the opportunity to share our Huawei Cloud Fabric 3.0 hyperconverged data center network with you. May God bless Africa. I thank you.
Thank you, Mr. Matamela. Our final speaker for our summit today is Mr. Lucas Amolo, the CTO of ICT and Smart City Solutions Konza Technopolis Development Authority, all the way from my favorite city in East Africa, Nairobi, Kenya. Jambo, Mr. Amolo.
My name is Lucas Omolo. I'm the manager in charge of ICT and smart cities at Konza Technopolis Development Authority. I work for a department called Business Development and Innovation. The objective of the institution, which is Konza Technopolis Development Authority, is to oversee implementation of Konza Technopolis, which is Kenya's first smart city project. It's meant to drive knowledge economy, IT-enabled services in our country so that we're able to move to the next level. And our focus is by 2030, we should drive Kenya into a middle income economy. We are building a smart city called Konza Technopolis. It is one of its kind in Kenya, if not Africa, a well-planned master city with all that it takes to enjoy the life and services in a smart city. And of course, from the definition of what a smart city is, Konza will rely on a robust technology infrastructure to support smart city facilities, to support the IoT that will be riding various services. We also rely on a very robust ICT network. So the data center is critical. It is the brainchild of our smart city, and that is why it is one of the first projects that we implemented. This data center will support smart city facilities in Konza. This is where various applications, for example, intelligent traffic system, smart parking, smart transport management, waste management will run from. Things like smart poles will all be channeled to the data center. Other than the smart city facilities, the data center is also critical because it will also support businesses. Konza is meant to be home for various startups, various businesses, and commercial enterprises. Some of these institutions coming on board will need a space to host the applications, a space to compute, and this infrastructure will be critical in providing that digital platform that will support various businesses, will also support us as the city municipal in running our city. Our demands for the data center, I think, are pretty clear because initially we did a business feasibility study to just establish what our needs are for this data center. And from that study, we got very good indications that we needed the data center to support smart city facilities. We also needed this data center to support the rest of government with modern cloud infrastructure. So we were looking at how we can have a very robust cloud infrastructure to support backup services, creating of cloud computing environment, disaster recovery services, email services, website hosting, among other things. So the data center, as I mentioned, is critical for supporting government, and government currently is digitizing a lot of its operations. And we believe the data center is well positioned to support the government of Kenya in its digital path. And we've done tremendous effort with our partners Huawei to ensure that we deliver the latest technology with data center infrastructure that will enable us not only support the city and the residents, but we are currently planning to support the rest of government with that digitization. We are using Huawei Cloud which is the latest infrastructure in cloud data center. Of course, it presents great opportunities both for us who are offering this cloud in terms of ease of management. We are relying on very dynamic management consoles. I want to give an example of software-defined networking that makes it easy for us to manage our network. And you can imagine a data center with a magnitude of 186 racks. The number of network equipment that are involved in that design. So these latest technologies like the SDN makes it easy for us to manage the network. Another one is Manage One, which we use to, of course, ensure that the other cloud infrastructure is monitored and is working well. We are also looking at platforms like Netico that is used to manage various facilities from generators to CCTVs, cameras, and the rest. So the technology that has been deployed, the cloud, the data center, plus all these management consoles makes it easy for us to manage the infrastructure, makes it easy for us to provision this infrastructure to respective clients. And of course, I like interacting with very dynamic graphical user interfaces for these platforms. So it presents a very innovative cloud infrastructure for us that one reduces the response time when we are provisioning resources. It also reduces the response time and the turnaround time to detect when there's a problem and even to monitor and manage the whole solution. So Huawei is a leader in technology, and Konza is striving to be a leader in technology in Kenya. So we chose Huawei. It was a deliberate decision because Huawei has gone at length to spur technology across the world, from offering cloud infrastructure and networking infrastructure, training, and even investment that Huawei as a company has made in research and development. Because for a company to be competitive, research and innovation is critical. We've seen even from different rankings every year, Huawei spending to the tune of 30% of its revenue in research. And that is a motivation that was important for us because we were looking at a very innovative city, a place where people will find technology enabling their businesses, technology enabling them to make decisions. So of course, for us, Huawei was the right partner to help us chart that path. And the investment that they've done for us is tremendous. We look forward even to work with them going forward on smart city facilities and various other services that will support this technopolis. And of course, the other objective for Konza that resonates well with Huawei company is we want to grow knowledge and innovation in our country. And one of the critical pillars in our strategic plan is knowledge economy and innovation. So we also hope that we need the right technology and a right partner to help us support the innovation ecosystem. So Huawei is right for us. And of course, we've seen from what we've done together in the data center. The benefits of the cloud data center, one is the flexibility. We've managed from the clients that we currently serve, it is easy to allocate resources to our clients. It's easy to manage the infrastructure. I want to give an example of the Huawei software-defined network, which is the SDN. So this is the latest network management platform that enables us manage the entire data center network as a cloud, as opposed to the traditional way of managing the network. We are also able to monitor various facilities of this data center from the generators, from the cameras, security, consumption of resources. So flexibility of cloud data center has shown immense benefits to us. Number two is we are also able to guarantee security. Currently, as a smart city, we intend to generate a lot of data from our cameras, from our sensors. So if we are only able to rely and give assurance to our clients that their data will be secure in our data center, then that is expectation of the market. So with the cloud infrastructure, we are able to easily manage security in terms of giving that assurance. Then the other advantage of cloud, of course, it becomes even easy for clients to manage their environment. It is, as opposed to the traditional ways of investing in hardware and difficulty even in scaling that infrastructure. Currently, we offer our clients a cloud environment which they can easily manage through web browser, through various other internet service browsers, and that makes it so easy for them to administer ICT in their respective institutions. The prospects for the future, I see a bright future for Konza. I see an area of innovation. I see an area where technology is enabling businesses to spur and businesses to grow. My prospects, of course, I'm looking at smart city facilities. So the most important thing, how Konza will be able to carry out the functions of a smart city. And I'm well convinced that our partner Huawei will work with us to deliver a world-class smart city for this region. And I see a bright future for Konza, I see a bright future for Kotda, and I see a bright future for Huawei in all this arrangement. So there's a lot that this infrastructure will support. I also see so many companies coming to Konza and piloting with our technology, riding on our infrastructure to support their businesses, riding on our infrastructure for purposes of skills transfer. And I also see an area where we will work with our partner Huawei to pilot and even implement these latest technologies like artificial intelligence. You are looking at 3D printing, blockchain, of course cloud computing, IoT, among other technologies. So there's a bright future for Konza, Kotda as well as Huawei. I hope you will find this session fruitful and interactive. I wish you all the best. Thank you.
Thank you, Mr. Omolo. I hope to visit you soon on your side of the continent. The key to new growth for organizations in this new era is digital transformation with leading ICT technologies. I hope that today we helped you gain an understanding of Huawei's IP technologies so that we can continue working towards building a fully connected, intelligent world together. Now, it's the question and answers part. If you have any questions, please feel free to ask. Thanks everyone for your warm discussions. If you have any questions later, you can send an email to our product managers. We have reached the moment you have all been waiting for, the Huawei Lucky Draw. And those of you who have completed the surveys will stand a chance to win one of 3 Huawei GT2 watches. There's no need to do anything as we have your contact information and will liaise with you regarding the logistics. We really appreciate your participation here today. I'd like to close today's proceedings by giving a vote of thanks to our industry experts who took the time to be here with us today. Last but not least, I'd like to thank you, our Huawei partners and friends, for being with us during this very trying and unsettling period. Be safe, take care of yourselves and your loved ones. Stay at home and God bless Africa. Thank you.